So yeah, I have some fun stuff. Today's a programming day, so if you would like to get started with me, go to scratch.mit.edu. You know the drill. And we get to make one of my favorite programs in Scratch today. We're going to make the Pong game. Hopefully we have all heard of that before. If not, look it up. It's very iconic. We're going to get there, slowly but surely, with Scratch. So today is all about building complicated programs from simpler pieces. That is programming in a nutshell, right? So let's get right on into it. I have a few examples before Pong, and then I promise to have us make a very fun game. So my first example is to teach you about clones. So I want to show you this silly example. We're just going to make a bunch of stars. It's going to look like they're all moving around, a bunch of shooting stars maybe. So let's make 50 stars in random spots with random sizes and directions, and then we'll just make them bounce around. Like, I don't know, we're traveling at light speed and all the stars are passing us by or something. Okay? So that's what I want to do. I want to teach you clones that way. There's a concept of a clone. That's just a sprite creating another version of itself. So this is one of the few programs where we don't need the Scratch Cat. So let's have a nice space backdrop. Where is it? Stars. Sounds good to me. And then I would like a star. Just the star sprite. That's good enough. There's my single little star. And the goal is for this little star to clone itself. It can make a copy of itself. So let's figure out where that is. It would make sense to be somewhere near here. Looks maybe. Not sound. What about control? There it is. So it's in control. It is create clone of myself block. You can also create clones of other sprites from the point of view of this star sprite though, but we want it to clone itself, so I'll zoom in here so you can see that. But if I were to run this block, boop, you don't notice anything happening, but if I move this, there are now 2 stars. If I click it again, boop, there are now 3 stars. A few times, there's just a bunch of stars just hanging out now. That was the last one. So that's pretty neat. You can make a bunch of clones of the same sprite and have them each do different things. They each have their own directions, positions, stuff like that. Isn't that cool? And if you want to go back to the original sprite only, you can click the stop button, and then all the clones get deleted. Back to the beginning. So yeah, let's make a program where we make 50 clones of the star, and then they all bounce around. Yeah? So here's the idea. So the original clone is like the orchestrator. It creates clones of itself, or the original star is the orchestrator. It creates clones of itself, and so we want 50 of them, right? We want 50 clones total. So how about we loop? Repeat 50 times, create a single clone of myself. So I did click record, right? Good. So if we do this 50 times, we will have 50 clones, right? Plus the original star. Click. There it goes. And that's kind of useless, right? Because all of those 50 stars are right on top of each other. Not really doing anything useful. So, okay. Let's not worry about that yet, because the next thing that I want to do is I'd like to have them bounce around. Eventually we're going to have them each teleport to new spots, but it'll be funny if we do this this time. Let's just have them all bounce around. So when a clone begins its life, it's different from the original star. This is the green flag clicked on the original star. Has nothing to do with the program for the clones. This is what happens when the clones begin their life. This is a program that we could put below here. This is the when I start as clone event. Okay? So when each star gets cloned and begins its life, it will run whatever is here. So that's where I want to put my bounce around forever, please. So forever, I don't know, forever move a little bit in your current direction, and if you're on the edge, bounce. So repeatedly doing that is going to have it bounce around, do cool stuff, right? Let's change the direction to something exciting. So if I run this program, the original star, the one in charge, is going to make 50 copies of itself, and each of those copies are going to run the same program, forever moving 10 steps, bouncing, forever moving 10 steps, bouncing. So you might think they're all going to be on top of each other, like I've shown you before, and you'll only see one at a time. But because it takes a slight amount of time, takes a few milliseconds to create a clone in a program, like that's some work that needs to be done, the clones begin their lives at slightly different times. And so the first clones are moving faster, or they start moving before the other clones get made and themselves start moving. So a cool effect happens when I click the green flag. Whee! There they go. So this was the one out in front was the very first clone. That one was created immediately, and then the second clone had to wait a little bit because it took time to make the next clone and the next clone and the next clone. But they're all right next to each other. So it creates a very cool effect. And then you have this original star just hanging out. Kind of done its work. So maybe the best thing for this original star to do is like get rid of itself, I would say. It can't really be part of the party because all the clones are doing this thing, the original star is doing this thing. I could kind of copy this here if I wanted to, but that's kind of ugly, I would say. So let's just let this original star do the work of cloning, and then it can hide itself. Okay? That'll be the idea. So let's do its looks, right? Just have it hide itself once it's done. So when you start as a clone, those stars should always be shown, but that original star can be hidden. Okay? So let's do it that way. So clone yourself, and then it goes away. And now we only have the clones hanging out. And when I stop the program, the original star is still not shown, but it should be fine because the clones immediately show themselves. Okay? Any questions about any of that? Because let's make it cooler now. But do we understand what's going on here? So, original star creating clones of itself. The clones do this other thing. Yeah, that's just how it works in Scratch. Pretty cool, though. So, I think the clones are very boring. So here's the original star again. Let's have them look like a Starfield, a field of stars. Let's have those stars start out in random spots and with also random sizes and directions. So when these clones begin their lives, they'll be, hopefully, I don't know, they can start out hidden maybe. But no matter what, I'd like to put them in different places. So go to a random position, clone, and then pick a random size and direction as well. So point and direction, I'll put a random number there. And then, where's size? Is that in looks? Probably. Change size by something, or set size to some percentage. So we can just put random numbers in here, and so it'll be different every time. Operators. So point and direction, it could be anything from 0 to 360, right? So pick a random direction, and then pick a random size, but still visible. So maybe we'll make it like, I don't know, 50 to 100, something like that. And so now all these clones, when they begin their life, they're going to pick random things for them to do, random places to be, random sizes, and random directions. And so then when they bounce off, they'll bounce off in just completely different ways, right? Because they'll all have random directions as well. Isn't that fun? So it looks like it's raining stars. And they're moving pretty quickly. Maybe they should move a bit slower. We can change that with the move how many steps. So maybe move 2 steps at a time, the stars. That's a bit more calming, I would say. So yeah. The original star makes a bunch of clones, and then each clone does this. Goes to a random spot, points in a random direction, sets a random size, make sure it's shown, and then forever just move in your random direction, bouncing off the edge if necessary. Okay? Any questions about this so far? Is this making enough sense? It's a cute little program, I think. You rerun it, it's all random, so it does different things. There are stars, they're so beautiful. I think the last thing that I would like to do, 50 stars, random spots, random sizes, directions, have them bounce around. The last thing I need to do is this. Let's get that depth effect going on. So you know how stars that are, or just anything in the world, like you look at a mountain that's farther away, it's more transparent than the ones in front of it. Let's do the same for stars. Let's make smaller stars let's pretend that the smaller stars, the ones with the smaller sizes, are farther away, and therefore they're a bit blurry. Let's make them transparent. So the way to manipulate transparency in Scratch is called the ghost effect. You change the ghost effect. So let's do that. It's up here in looks, I think. So it's change, not color effect by 25, it's like change ghost effect. Okay. And we'd like to change the ghost effect by, let me show you how this works for the original sprite. So let me show the original star. You change it by 25, ghost, that makes it 25 less bright, 25 more transparent. So now it's 50% transparent, 75% transparent, 0% transparent. That's the idea. So let's keep our stars between, I don't know, 100 transparency and 50 transparency. I think that's fine. So I think the ghost effect needs to depend on the size, right? First of all, it needs to depend on the size. So can I get my current size? Yeah, I can. It's a size variable. I should change the ghost effect to like 100 minus size. I think that's what I want, right? Because then smaller sizes will have their ghost effect changed by more. If the size is 100 already, then computing change ghost effect by 100 minus size, which is 100, makes change it by 0, so don't change it at all, right? So if size is smaller, that will make it more transparent. Do you see how I'm reasoning about that? So if size is 50, that'll make the ghost effect, it'll change it by 50. If the size is 75, it'll change the ghost effect by 25, which is a little bit less because it's bigger. If the size is 100, it'll change it by 0, so keep it fully transparent, or fully opaque, that's the word, right? There they go, and so the smaller stars are now more see-through. They're more transparent, they're farther away. At least that's what we're pretending. Okay, so that, I think, is everything that I wanted to show you. Are there any questions about this? Maybe we can make it move even more slowly. I'll be even more calming. There they go. Are we good with that first example? Just the idea of clones, mostly. And then each clone can have their own program that they run when they begin their lives. All right, let me save this so I can give it to you later. Are we ready for another example? Off we go. So, next example. I want to go back to our Do You Believe in Ghosts program. There's a much easier way to write that program. We just didn't have the tools at our disposal. I want to teach you a new kind of way of programming in Scratch. It's called message passing. That's really going to help us here. That's going to make it so that the ghosts don't have to have a forever loop that watches for a variable to change. That was kind of ugly. So in message passing, there's a concept of a sender and listeners. Sender and listeners. And here's the idea. So the Scratch cat is the one saying, I believe in ghosts or I don't believe in ghosts. Essentially, that's a message to the ghosts, right? Scratch. Here's the Scratch cat. And then here are all the ghosts. We had the skeleton, the actual ghost, and the bat, right? That was what we were using. So here's the skeleton, the ghost, and the bat. And the concept of message passing is very simple. It's just that the Scratch cat can make a little message that it wants to send, and then it can shout it out to anybody who wants to listen to that message. You can say, I believe in ghosts, or I don't believe in ghosts. And all of these other sprites can be hooked up to listen for that message. Okay? And so they'll hear, like, I believe in ghosts, I should show myself, or I shouldn't show myself. Okay? So we're going to make two kinds of messages, a hide ghosts message and a show ghosts message. I'm going to show you how that works. All right? So where can I say all these things? Motion looks. Let me find the messages. Are they down here? No. Set drag mode. There it is. It's in events because a message is kind of like an event. So we can change these. We can make new messages. When I receive message 1, broadcast message 1, and wait. So we're going to make 2 new kinds of messages that we could send to anybody. We're going to make a show ghosts message. I wonder if I can just change the name of this one. Doesn't look like I can. Yeah, let's make a show ghosts message. Don't know why I'm using capitals and spaces, but I can. Show ghosts message and a hide ghosts message. Oh, and shoot, I need to clear this out anyway. New. There we go. Let me do it one more time. Show ghosts. Now I'll be lazy and do it all lowercase. And hide ghosts. Okay, so let's get back to where we used to be. Now I have those messages ready to go, ready to be sent. Let me make my spooky backdrop. Where is that? Is that the woods? Is that the name of it? Woods. Scratch Cat's over here. And then we had a skeleton, a ghost, and a bat. Alright. There are spooky ghosts. And there's the Scratch Cat. So here's how I'll change the program. When the green flag gets clicked, we need to do the same stuff the Scratch Cat asks, or the program asks. That's just from the Scratch Cat's program right now that we're working. Scratch Cat asks, do you believe in ghosts? And wait. And then based on the answer, we're going to either show the ghosts or hide the ghosts. And they should start out hidden. So we'll deal with that in just a second as well. But based on this answer, we should do something or something else. So if the answer is yes, then we should show the ghosts. Otherwise, we should hide the ghosts, yeah? So that's in operators, check for equality. So if the answer was equal to yes, then I'd like to yell at the ghosts. Send them the message, right? The program should send the message for them to show themselves / hide themselves. So that's over here in events. So we want to broadcast. Did it really go away? Oh, man. All right. I'll do it again. Show ghosts. We will broadcast show ghosts if the answer is yes. And then we'll broadcast hide ghosts if the answer is no. Or something other than yes, right? Does that make sense? Just yelling at the ghosts and expecting them to listen. We're going to hook them up in a second to listen for these messages. Because this is going to make it so simple to write this program from the ghost's perspective. No more infinite loops checking for a variable changing. And then also I want the ghosts to start out hidden. So at the very beginning, just say, hey ghosts, hide yourselves, just in case you're already shown. And now watch what I can do. This is the skeletons program I'm working on right now. When I receive hide ghosts and when I receive show ghosts, I want to do one thing or another thing. I'd like to either hide or show myself, right? Because I'm a ghost. When I receive hide ghosts, I want to hide. When I receive show ghosts, I want to show. That's what I want to do when I receive those messages. Do you see how simple that is? That's really 2 lines of code. You just hook it up to these messages. That's super nice. So let's give this to everybody. Boop. Boop. All the ghosts at least. Boop. Boop. So the skeleton does that. The ghost does that. The bat does that too. That's just when I receive hide ghosts, I hide. When I receive show ghosts, I show. That's what I want to do in response to those messages. No infinite loops needed. No loops needed at all. So I run the program, broadcast hide ghosts. That told them all to hide themselves. Then, do you believe in ghosts? If I say yes, we'll broadcast show ghosts, and they're all listening for that. And oh man, do they show themselves. Isn't that beautiful? And then if I say no, they're not going to do anything because they're already hidden. Like, technically, I don't need this else part. I could just make an if only because they're already hidden. But, I don't know. Might as well keep it easier to reason about. So that's message passing. You create these little messages, and then and then you can shout them out to anybody who wants to listen for them. And then the people who are listening for those messages, once they receive them, they can do something. They can have a little program that runs and do cool stuff based on that. Okay? So much simpler than the version that we had before, but I had to teach you a new thing to get here. Okay? Are there any questions about this program? All right. So I'll save this and give it to you later. I won't give it to you now. I have a question for you. All right. I just want to give you some time to play around with these new concepts. So cloning and message passing. Here's my little question for you. So assuming you haven't already tried, maybe you have it in front of you already, but try and recreate that example. I'll give you 5 minutes to play around. And if you have extra time, make those ghosts say boo or something. Make like 1,000,000, make like 200 ghosts appear and they're all transparent or something. So play with message passing as well as cloning. Maybe you can make a new message and have like a third option. Do you believe in ghosts? Maybe if you type maybe, only half the ghosts appear or something. That would be interesting. So I just want to give you 5 minutes to play around, make something cool, and help each other. Okay? And ask me questions. So I'll set a timer, go off and have fun for a little bit, and then we'll come back and make Pong. Oops. Today's the 31st. Take another 2 minutes to have fun. Cool. All right, I hope that was fun and you got some cool stuff written. Were there any questions that came up while we were playing around that I could answer? Or are we ready for Pong? Okay. So, yeah, just in case you forgot, here's what Pong is. We're going to make single-player Pong. I'll give you plenty of time at the end of class if you want to play around and try to make double-player Pong, two-player Pong. But here's going to be how it works. We're going to have a paddle on the left side, and we're going to have a ball that starts off, hopefully moving towards the paddle in some direction. And then here's the game works like this, right? The ball bounces off the paddle, hopefully, up and down and up and down. It bounces off all the walls, and you're supposed to keep hitting it, right? Bounce, bounce, bounce. If, however, it bounces and it goes through your paddle and hits the left wall, that's when it's game over, right? That should stop the game. So we're going to create all of those things. We're going to make Pong. So let's try and do all this stuff, and then, yeah, it'll be cool. I'll give you plenty of time to play around with that too. So, can't remember if I saved this one or not. I believe I did, but I honestly don't know. So save that one, just in case it was different. Looks like it was not at all, so that's good. And then I'll make a new one. So again, unless you want the Scratch Cat to be the ball or something, we'll get rid of him. And I don't know. Keep a white backdrop for now, unless you want to find another one. We're going to need a ball, first of all. We're going to need a ball, we're going to need a paddle. Conveniently called paddle, there it is. And we're going to need, to make it easy to know when we lost, I'm going to bring in a sprite called a line. It's called line. It's the big long line is what it is. This will just define the edge of how far you want, or when you lose. Like if you're touching this line, you have lost. So let's change all these directions so it looks right. So let's make this direction 0. Can't quite do it with my mouse, can I? There we go. Now I'll put this way over here. So if the ball ever touches this line is the thing, then it's game over. That's how we want it to be. That looks good. Can I make it go even further? Not really. Okay, so the line's over there now. Now the paddle's in the wrong direction, so let's make its direction 0 as well. And then the ball looks like a good size, but the paddle looks a bit weird. Maybe we should change its size to, like, I don't know, 150. Does that look better? Yeah. What does 200 look like? That's way too big. That's too easy. 175. I like 150. So yeah, these are the main elements of our game. We have the paddle, we have the ball, and we have the little line that tells us if we hit it, the game is over. So yeah, okay, so first thing, how about we get the paddle working? Instead of up arrow, down arrow, I think it's a bit more convenient if we just have the paddle follow the mouse pointer. So if we move our mouse up, the paddle moves up. If we move our mouse down, the paddle moves down. Won't that be cool? So there's some events for that when, I don't know. I guess we can forever keep checking things. So maybe when the green flag gets clicked and the game starts, oh sorry, let me go to the paddles program right now because we're working on the paddle and having it move. So when the green flag gets clicked and the game begins, we would like the paddle to follow the mouse pointer forever. So let's do that. So forever, Mr. Paddle, please follow the mouse pointer. And so the way we do that is we have some very, very nice variables here when I find them. Not that one. Point towards the mouse pointer, no. Change x by that, no. We're eventually going to maybe need those, but there should be a mouse, some mouse variables somewhere. I'll find them eventually. There they are. They're in sensing. Here they are. So we have mouse x and mouse y. Mouse x is the x coordinate of where the mouse is, and mouse y is the y coordinate of where the mouse is. So which one do I want? If I move the mouse up, I want the paddle to move up. Is that checking for the mouse y changing or the mouse x to change? It's y, up and down. I don't care about left and right. That shouldn't move the paddle. It's only up and down that should move the paddle. So get rid of that one. So we're going to keep on looking at mouse y, and we'll set paddle's y to the same thing. Okay? Forever, set my y to whatever the mouse y currently is. It'll change every time I move the mouse, of course. Just keep it in sync. Does that make sense? Whee! There it goes. And so now I can move the mouse way over here. It's just keeping track of the y. It doesn't matter where my mouse is. It's keeping track of the y. Forever set the y of the paddle to the mouse y. We don't care about the paddle's x because that would move it left and right. That wouldn't be good. And yeah, it's only the y, only up and down. We're using the mouse's y to set the paddle's y. So right in the middle is looking pretty good. Does that make sense to us all? Why it needs to be that? That's pretty fun. You can stop this happening when you press the stop button, of course. And it will always, once you press the green flag again, it'll set it back down to where it needs to go. That's pretty nice. So stop. Now let's work on the ball maybe. Okay? The ball needs to bounce around, right? So let's get the ball bouncing around just like we had the stars bouncing around. The ball always has a direction. Let's give it some random one right now. We'll change it later. And then the ball needs to bounce off, right? Ball needs to bounce off with that random direction. So, all right, ball whenever the game starts, events, green flag gets clicked, the ball should just keep on moving, right? Forever, move in its current direction, bounce if it hits a wall. Something like this. If on edge bounce. Yeah? So that's the ball's program. Here's the paddle's program. Paddle needs to follow the mouse. The ball just needs to bounce around. Whee! There it goes. That's quite nice. Any questions about what I have so far? Because we're getting there. That wasn't too hard to make just this. We kind of need to hook in the paddle to the ball. And then also right now, look what happens. If I stop the program here and I start it again, I immediately lose, right? Because the ball is going to keep its same course and immediately hit the wall. Like I had no chance at that. So I think we should fix that first. When the ball starts, when the program starts, let's put the ball on the right half of the screen, first of all. Let's pick a random place for it to go. So, I don't know. When the ball begins its life, let's put it on the right half of the screen. So, what is that? Positive x values, and then the y can be anything. So, set x, set y to something random. But meaningful. So the x, when the ball begins its life, I don't want the x to be way over here because then the ball might bounce into the wall immediately before we can get the paddle there. So let's have the ball only have positive x coordinates. So from 1 to as big as it can be, right? 1 to, I don't know, 200. And then the y can be whatever. Like the ball, as long as it's on the right half, the y can be negative 150 or positive 150. I don't care. Something like that. And now, whenever I start the program, the ball is going to be somewhere on the right half, moving in some direction. Right now, it's just whatever it used to be. So I think we should also make the direction random, right? The ball's direction should be random as well. So I'll bring a random thing in here because I'm going to need it. Let's have the direction be some random direction between 0 and 360. I don't care what. Just give me a new thing each time. So sometimes it's moving towards, sometimes it's moving away. Doesn't matter. That looks like a game that's random to me. Okay? Any questions about what I needed to do there? Because that's doing pretty well, right? That's pretty close. Pretty close to Pong. The only real things that are missing right now is ending the game and then also bouncing off the paddle. Yeah? Are we good with what we have so far, though? Do all these choices make enough sense to us? They weren't just random choices. They are game design. Okay. Let's see. How do I want to do the next thing? What we need to do is let's hook up the paddle and the ball first. So I think a good place to check if we hit the paddle, let's do it from the ball's perspective because the ball's the one that's moving. So in sensing, there's a nice am I touching something block. That's a condition. We can ask the ball, because it's always from the ball's perspective if this is the ball's program, we can ask it, hey, am I touching the paddle? It's false when it's not, and I put it over here, and true when it is. So depending on whether or not it's touching the paddle, we can bounce off. Does that make sense? That screams if block to me. So if the ball is touching the paddle, then we need to bounce off of it. Bounce off. That'll be what we do. So if the ball is touching the paddle, bounce off of the paddle. And now we need to talk about bouncing, because this is going to be fun. So I'm going to do it an easy way right now, and then we're going to figure out the hard way in a future lecture. So here's the paddle. Here's the ball coming in. Ideally, if it were perfectly correct, the ball should bounce off this way, right? I would like you to think about how to do that after class. The easiest way to do this bouncing is to just say, all right, the ball's coming in at the paddle. We know that it's touching. Let's just flip the ball 180 and then have it bounce off this way. Yeah? That sounds good to me. Does that make sense? I think that seems fine. So if we ever touch the paddle, we'll have it bounce off. Whee! We'll bounce off by, what does it mean to bounce? Change your direction by 180. Flip around so that you're moving the other way now, away from the paddle. Yes? That's the idea. So point and direction, well, whatever the current direction is, plus 180. Yeah? Point and direction, whatever your current direction is, there's a variable for that, plus 180. That'll bounce off in the opposite direction. Okay? Does that idea make sense to us? So the ball just keeps on checking. If it's touching the paddle, then it'll bounce off by just moving around, moving the other way. So it still works, but now when it's touching, it's like, all right, I'm going to change my direction. I'm going to flip a 180. Whee! There it goes. Isn't that fun? Any questions about this? Because that's already exciting. It's not bouncing in the way you'd think it would, but that's okay. Who cares? You can come up with a mathematical expression to do that on your own, then I'll do it in a future class. But that is the game so far. Are we still good with this? Ready to finish it? Checking my notes, I think last time I tried to be a bit cooler with how I started the ball off. So the ball needs to be on the right half of the screen, but let's have it so that the ball isn't, let's give ourselves some time. Let's make it so that the ball isn't immediately like coming towards us. Let's make it so that the ball bounces off like, I don't know, between an angle of 40 and whatever that opposite is, maybe 140. Okay, how about 40 and 140? That can be our random direction. It'll always be bouncing off to the right if we do that. To the right, to the right, to the right, to the right, to the right. Maybe that's a bit better. I don't know. That is a design decision for you, the programmer. But it'll still work just fine either way. So that's the ball, the paddle, and really the final main piece of this program to get it working, at least basically, is to lose the game. We need to know when the game is over. We need to notice that. So when is the game over? It's if the ball ever hits that side wall that I have just so conveniently placed a line on. So now I can ask that touching question again. If the ball is touching that line, then the game is over. You see how nice that is? That's why we put the line there. So we can do that from the line's perspective. We can make a program for the line now. The line can just keep checking, hey, is the ball touching me? So forever, keep checking. Am I touching the ball? If so, if that ever happens, the game's over. So in control, so if I am touching the ball, I'll check until the end of time, but the second I'm touching the ball, stop the game. That's the stop block, yeah? Can't put anything below the stop block. It ends everything. Stop all. Cool. Does that idea make sense? So the line can just repeatedly check if it's touching the ball. If so, stop the game. You could equivalently put this in the balls program again. So like if it's touching the paddle, bounce off. If it's on the edge, bounce off. If it's touching the line, stop the game. Maybe that's more logical, but let's give the line something to do too. Why not? So now we'll play the game. It'll bounce off of the paddle if we let it, but if we accidentally miss, then it should run that if statement. Boop. And it stops the game. I can't even control the paddle anymore because that stops everything. How nice. And if I restart, everything gets reinitialized back to normal. And I can lose all over again. Boop. Isn't that cool? Are there any questions about that? I think the last thing that I would like to do is show you how to make your own sprite. You can make a custom sprite. Let's make a you lose sprite or something, and have that appear when the game is over and you've lost it. So instead of choose a sprite, let's paint a sprite. I can put some text, be like, you lose sad face. I can make it giant. I think that works. And now it's just another sprite. You can call it whatever you want. Call it you lose, game over, I don't know. We can just show that. So this is in the costumes tab right now. I can go back to the code tab. We can, I don't know, when the game begins, how do I want to do this? When the game begins, we haven't lost, so this sprite should hide itself, right? But when we lose the game here, before we stop everything, we should show that sprite. I think we could have a message for that. Tell that sprite to show itself. So I can have a game over message or something. So broadcast game over when we've lost the game. The game over sprite will be looking for that. When it receives the game over message, it can show itself. Do you see that interplay between this new sprite and then the line? It's controlling when it shows itself. At the beginning of the game, of course, it's not over, so hide the you lose sprite. But when the game is over, we'll send that, we'll broadcast that game over message, and it's the line that's doing it, but it's the game over sprite that's listening for it. It will show itself. And then all should be well. So, boop, boop, boop. I play the game. I'm winning. If I lose, boop. We broadcast game over, show the sprite, and we're good. Any questions about how I did that? It's very similar to the ghost example. But now it's maybe a bit more interesting because it's part of a game. We're good with that? So yeah, I think, let me save that, and I can not give it to you. I think the last thing that I want to do is, we have plenty of time. Let me give you another 5 minutes to play around with this stuff. Try and, I don't know, fix the bouncing, see if you can figure out the proper direction that it needs to bounce off of. Maybe you can change these sprites. Maybe you can make it 2-player. You'll need the keys for the other paddle, maybe. How could you make it 2-player? Would it be pretty easy? Would it be very similar to this? Very similar to bouncing off? Have a paddle 1 and paddle 2? Something like that? The ball needs to notice if it's touching both paddles now, doesn't it? So yeah, there's a lot going on there. Let me leave it on the balls program, maybe. That's the most complicated one if you want to look at that. But I'll give you, I don't know, take 4 minutes to play around with whatever you have so far. Make something cool. Maybe you can make multiple balls appear. They can clone it themselves. Extra hard version. But yeah, see if you can play around with this, because that will definitely help you understand it. That's the whole point. And then the last thing for the day will be your next programming assignment. So that will be what I release once my timer goes off. Are we done with attendance, by the way? Can I stop that? Yeah, let me know if you have not done it. All right. Cool. Let's see here. Yeah. All right, take another minute. Alright, that is my timer. Did we make anything fun? I'd like to see like 50 balls trying to play the game with that. Maybe you lose only after every single one of them has hit the wall. That'll be really fun to program, I think. So, we're good with this. I believe I have saved it. There it is. The last piece of business is your next programming assignment. So this will be a 2-week assignment, due week 6. Here is your next one. Here's what I'd like you to do. I would like you to implement the Space Invaders game. If you've never seen it, it's very fun. Another iconic one. But this nice man has made a video that teaches you exactly how to make Space Invaders in Scratch. I want you to watch the video and follow along. Okay? You are allowed to change the game, of course, as much as you want. You can use different sprites. I think for some reason he chooses to use tacos as bullets. Or no, tacos as aliens to shoot. Yeah, that's it. You can do whatever you want. As long as you end up matching the same thing. I want to show you him playing it, though. This is kind of what it looks like. Come on. Towards the end. There it goes. So, yeah, something like that. They're flying around, and you're shooting, and things like that. So that is a fun game that you will program, and you can manipulate it as much as you want, as long as the original features of the game are still there. You can make it more cool. That would be nice, but you're not required to. And then for submission, just upload a video. Just show me your program running. It looks like Space Invaders. It's doing the right thing. Show me your code. And yeah, just explain how it's working so that I know you didn't just blindly copy everything. Okay, that's what I want for you. If you have not programmed, this is your first class on programming. But if you have already programmed, here is your default assignment. Chapters 1.7 and 2.1, exercises 9 and 11, and just as usual, record a video, please. Show me that you got your programs working and they're running properly. Okay, so yeah, those are the assignments due in 2 weeks. Are there any questions about either of them? All right, that's all I got for you then.